Today, I'm going to explain Kubernetes to you and its main concepts. We'll talk about nodes, pods, services, and much more. We will also explain their use case and role in Kubernetes. But before all of that, let's understand Kubernetes. At its core, Kubernetes is an open source container orchestration platform developed by Google. Container orchestration, in simple terms, is the management of your containerized application. It also automates the deployment and scaling of your application. So what are the key concepts behind Kubernetes? Let's break it down into a few main components. First up, we have nodes. These are the worker machines where your containers can run. They can be physical servers or virtual machines in a cloud such as AWS or GCP. Nodes are the backbone of your Kubernetes cluster. If a node ever crashes or something happens to it, Kubernetes will easily replace it by shifting the load distribution to another node so that it's ready for deployment. Now, within these nodes, we have pods. A pod is the smallest deployable unit in Kubernetes, containing one or more containers. They share the same network, namespace, and storage, allowing them to communicate easily. Every pod most likely has a replica or replicas. Kubernetes automatically scales the pods based on the load. To enable communication between the pods, we use services. Services provide a stable endpoint to access a set of pods. In Kubernetes, communication is based on IP addresses and endpoints. However, when a pod dies, the replacement gets assigned a completely different IP address. So, to ensure a stable connection between the pods, we create services. Here you can see we have a Kubernetes cluster. Now, we are receiving traffic from the web application. The web application sends the traffic to the load balancer, which will direct the traffic to the service. The service receives the request and gives the request to a pod. It will wait for the response and send it back to the web application. Next up, we have deployments. These define how to create or modify the pods you are targeting. Deployments can help you scale the amount of replica pods and control the overall performance of the pods. Here we have a deployment. Now, the replica set is going to check how many replicas is desired. It will check in the YAML file for the number of replicas in the specification section. Now, you can see the replicas have been made. The last component we're going to talk about today are config maps and secrets. Config maps are a way to store data in a Kubernetes cluster. Think of it like a key value pairs that hold information about how your application and services should behave. These configurations should include non-sensitive information such as environmental variables. Config map helps keep your application's configuration separate from its code, making it easier to manage and update. Secrets, on the other hand, are used to store sensitive information in a Kubernetes cluster, such as passwords, API keys, or any confidential data. They're like locked vaults for your private information. Using secret ensures that sensitive data is kept secure and is not exposed in plain text. Kubernetes takes extra precautions to encrypt and protect this data, making it a safer way to manage sensitive information within your applications.